NCBM 0324, Section 1.4, Evaluating Functions Using Function Notation, Part 3. Let's look at another one of these more simple functions, and let's see what else we can do with something like it. We have on this one, g of x is equal to 3x plus 5. So without even looking at what we're going to have to do with it, I'm going to write down my skeleton. So I have a variable only in one place, one spot here, 3 times that x. So I'm going to put 3 times my parentheses. That's what's going to get plugged in, plus that 5. So in my first one, we're looking for g of t. So t is my substitution. That's going to go into the skeleton part. So that t goes in here. Can we simplify this anymore? There's really nothing. Just a matter of switching our variable to that t. So we have g of t is equal to 3t plus 5. And that's it. Variable is our substitution, so it should be in our answer as well. What about g of negative 9? G of negative 9. So now back to a number. Just don't forget we can also plug in numbers. So into those skeleton spots, I have a negative 9 in there. So starting with my skeleton, I'm going to take that negative 9 and I'm going to plug it in. And then here I can do a little more work because I do have a number, a value. 3 times negative 9 is negative 27 plus the 5. We're going to have g, go ahead and write it over here, g of negative 9 is equal to negative 22. So we do have a y value, an actual number. We can look at and maybe graph if we needed to, or whatever the problem calls for. Next one, g of x minus 3. So this is my substitution part. That's going to go into the blank spots of my 3 parentheses plus 5. Whatever's inside of here, no matter how complicated it may be or not, that gets plugged into that space we made. So I now have 3 times, in parentheses, x minus 3 plus 5. So let's simplify it. Let's expand those parentheses. Let's actually get rid of them. So order of operations, when I multiply that 3 in, I'm going to have 3x minus 9 plus 5. So we're going to have that the function g of x minus 3 is equal to 3x minus 4. So the function g of x minus 3 is equal to 3x minus 4 is our answer. So a reminder, just now that we've practiced and we've worked with some of this notation, remember this set of parentheses on the left over here. This does not mean g times x minus 3. This is telling me that I'm plugging in x minus 3 into the original g function that they gave me. Right? I'm building a new function with it. But this is not multiplication. We're substituting in one piece into a previous function. Now the last one. And this last one is very important. This is something you'll use in your future classes. So we have g of x plus h. So not only do we have an x again, but I now only have a variable that I'm adding, right? I'm not plugging in a number like we did in the last one, right? That x minus 3, we had a number being subtracted. In this case, we have 2 variables that we're plugging in with this addition in between. And maybe we may think that things are going to change drastically, but really, what is the process for evaluating? Whatever's inside gets plugged into that spot we've saved. That spot that came from the original variable in the original function. So in this case, what am I going to plug into the 3 parentheses plus 5? The 3 times the parentheses plus 5. I'm going to plug in x plus h. That's all inside of parentheses. So I know that is my substitution. That's the evaluation part that I'm doing. After I have that plugged in, I'm going to simplify a little bit. Let's get rid of those parentheses. So I'm going to have g of x plus h, this new value that we found by doing the evaluation, is going to equal to 3x plus 3h plus 5. And everything in there is different. There's no like terms, there's no common values here that we can combine. So that is, in fact, my answer. So not only do I have x's, but I also now have this other variable h, right? And that's okay because it's coming from the substitution part we made. Let's try that again.